welcome all. Lovely greetings to all dear students who are waiting for this episode. My name is Naveen Karki and I'll be presenting you the discussion today, the discussion of permanent magnet. और ये जो class है, this is being aired live in Airtel Television. और class के दौरान, if you have any sort of difficulty regarding the ongoing topic, इसके अलावा और नहीं, just regarding the ongoing topic, then please WhatsApp me your queries in this number 9311883484. So this is the WhatsApp number. So please send me your queries या class के दौरान any sort of question that we would be asking. If you would like to respond on that, then also the channel is open. And please do remember, no other screen apart from WhatsApp that will be visible to me. So please just stick to the WhatsApp one. And for the old students, you know, the medium of communication we are going to keep 80% English and 20% Hindi. इस तरह से हम medium of communication को रखेंगे. So I'm quite excited today just to present you the idea of permanent magnet, and if time permits, we'll be extending it to Earth's magnetism as well. All right? Okay, good to go. Now let's begin. Let us begin. In the idea of permanent magnet, the first and foremost thing, let me tell you that this topic is important for both NEET as well as JEE main. हालांकि जो if I just talk about the recent JEE main question paper, बहुत सारे questions straightforward, बहुत simple approach में that could have been solved. तो आज की जो date में I don't see any much level difference between NEET question paper and JEE main question paper. They are almost the same. So in that regard, this discussion is valid for both the JEE main as well as the repeater. Or who are preparing for NEET, उनके लिए permanent magnet, almost you would get a guaranteed question. And for those students who are preparing for JEE main, आप सभी को इस बात की जानकारी होगी that there are certain syllabus which are not included in JEE Advanced, like permanent magnet, electromagnetic wave, semiconductors, principle of communication. और JEE main क्या करता है कि इन topics, जो topics JEE Advanced में included नहीं है, they make lots and lots of questions from these topics. So in that regard, this comes out to be a very important one. All right? So I hope all of you are completely excited to begin with. शुरू करते हैं. Let's begin. Lots of background has happened. Okay, to begin with, the first thing is that अगर हम permanent magnet की बात करें. Now, first, let me just talk about a bar magnet. Okay, उसके बाद we'll just extend the discussion to others as well. So this is a bar magnet. Now, permanent magnet की जो study है, that is taken in a very, very comparative manner to dipole of electrostatics. Let me repeat it again. The study of permanent magnet is taken in a comparative fashion to dipole of electrostatics. So it's time कि dipole से related, electric dipole से related जितने भी expressions आपके पास थे, just ensure that they are completely at the top of your head right now. Every now and then, we are going to utilize it. Let us start from the first discussion. Well, in case of this, we have a south pole and we have a north pole. Yes? और एक चीज हमें पता है that magnet, the permanent magnet, never ever exists in monopolar form. हमेशा dipole or the magnet would exist in a dipolar form. So in that regard, you could say this is always dipolar. और इसका डाइपोलर होने का एक बहुत स्ट्रॉन्ग सिग्निफिकेंस है, and let me show that significance. Let's try to see. First of all, if you have a magnet and you know that it is always in a dipolar form, right? There's a very beautiful thing. Let me just show it to you. Now, this is that particular magnet. Okay, so something here. And you know, this is south, this is north. Now, let me talk about the field lines. Let me talk about the field lines. And there's a major difference between electric field lines and magnetic field lines. Electric field lines, you know, they are discontinuous, jabki magnetic field lines, they are continuous. Yes? So if I talk about the field line, typically, this is how it goes, outside and inside. You know, guys, there's a very interesting, there's a word in English. अब आप कहेंगे कि in the physics class, why we are interested in those terms. सबसे पहली बात तो I have my personal interest towards multiple languages. So English is one of them. उसमें से, see, you have one word that is called as comparing and another is called as contrasting. अच्छा, डे टू डे लैंग्वेजेस में या डे टू डे एप्लीकेशन में अपने दिनचर्या में हम काफ़ी ज़्यादा इसे मिसयूज करते. We use it in a wrong manner. But you know what? Comparison means finding similarity and contrasting means finding differences. Let me repeat it again. Comparison, finding similarity, contrasting, that is finding differences. But अगर मैं भी अपने घर पे if I have to use the word जहाँ मुझे differences दिखाना है वहाँ पर I use the word comparing क्योंकि day to day life में we don't go into grammatical correctness. हम rather ये देखते कि किससे अच्छा sense बनता है. अब आप देखिए कि suppose if you are siblings तो आप अपने parents को क्या कहते हैं? Please compare मत कीजिए. मेरे भाई के साथ please don't compare. वो एक अलग है, मैं अलग हूँ. So rather सही शब्द क्या होना चाहिए? Please don't contrast. Contrasting का मतलब to find the difference है, compare का मतलब to find the similarity. Now coming back to the point, when you talk about magnetic or the magnetic study entire, you need to compare and contrast with the electric field. You need to find the similarity, you need to find the differences. And trust me guys, जिस दिन से आप similarity और differences को अच्छी तरह से रेसा रेसा अलग करोगे, if you start separating the strands, believe you me, your study is going to be very, very perfect. Now, let's say the first contrast is that magnetic field lines, they are continuous, right? They are continuous. Bahar, north to south, inside, south to north. And if I just draw another one, this is how it comes, right? Now, being dipolar होने के कारण से, there is a very wonderful consequence of this field lines. और वो क्या है? Let's try to understand. You see, you could understand in this given way that the magnetic field lines are continuous. Okay? Now, what I do is that, let me draw a surface here. This is a surface, and that surface, we will call it as the Gaussian surface. आपको लग सकता है कि आज क्लास के beginning में ही काफ़ी भारी भरकम बात हो रही है, but they are very, very simple. And they are very important. I never discuss those things which are not contextual for the examination. देखो, यहाँ बैठ के, just to show my muscle power in physics, that is not my purpose. Purpose ये रहना चाहिए कि after having attended this class, you should be able to solve the question of examination. That is the ultimate purpose. So let's see, I made a Gaussian surface. It's a closed surface. It's not a line. Now, if I try to apply that, you would get integral B dot ds. Now, in electrostatics, it was E dot ds. right? Electric field dot ds, but here it is B dot ds, and this will always be 0. ये हमेशा ही 0 होगा. और इसी को we also call it as the Gauss's law in magnetism. This is also called as the Gauss's law in magnetism. You get my point? This is called as the Gauss's law in magnetism. Integral B dot ds is equals to 0. Now, why is it? The reason is very, very obvious. You know what? आप ये Gaussian surface पे देखेंगे, for every incoming field, जरा ध्यान से देखें, this field is incoming. Look at the direction of the arrow. There is an outgoing field. Let's repeat it again. For every incoming flux, या field equivalent है, there is an outgoing flux. और हमें पता है, in the language of flux, the incoming flux is treated as negative, while the outgoing flux is treated as positive. उसका एक खास कारण है, let me not discuss that. But the incoming flux is taken as negative, the outgoing flux is taken as positive. And whatever is the value of negative, the value of positive is exactly same. That is the reason why this is always 0, and there is no exception for this rule. Never ever. जबकि electric field के केस में closed surface integral E dot ds may be 0, may be non-zero. Both the possibilities are there. But magnetism के केस में closed surface integral B dot ds is always and always equals to 0. Okay, that's one of the wonderful property that we got. Okay, so I hope this is the first thing that has really been placed in your head. Now let's move further. Moving further, guys, let's try to understand. Okay, let's come to this particular point. यहाँ देखते. Here is the South Pole and here is the North Pole. All right, and मैं इन छोटी-छोटी बातों पे I'll not be consuming my time. That South Pole or North Pole would not be in the extreme, but they would be slightly inside. So one is called as the magnetic length, the other is called as the geometrical length. Those stories are there. Let us not consume our time for those cases. The south is always equivalent to negative charge, and the north is always equivalent to positive charge. But this is not electric charge. This is magnetic charge. Okay, so here what do I get is this is QM. What did I do? I gave a subscript M ताकि confusion ना रहे, because Q has been used by us for electric charge. अब जिस चीज को हमने इतने बार पढ़ लिया है, the moment I say Q, you know, in your brain, subconscious में, electric charge will appear first. So it's always better that we make a distinct convention. QM is for magnetic charge. और ये ध्यान दीजिएगा, the south pole is always equivalent to negative QM and the north pole is always equivalent to positive QM. बहुत ध्यान से देखें, I haven't given equality sign, I have given inequality sign. Okay? Anushka, there is a question here. Can we say that it is 0 because no moving charge is present in the Gaussian surface? Anushka, this is not the valid reason. Moving charge तो है. As a matter of fact, एक permanent magnet का जो magnetic behavior है, that is the outcome of electron in an orbital motion, of their inherent spin and all those things. So Anushka, let me repeat the question what Anushka has said so that I can address it. Can we say that it is 0? It का मतलब, she means to say the Gauss law is 0 because no moving charge is present in the Gaussian surface. This would not be the correct reasoning, Anushka, because मैग्नेटिक फील्ड, द मैग्नेटिक बिहेवियर कहीं पर भी देखो, चाहे एक परमानेंट मैग्नेट के द्वारा जो मैग्नेटिक फील्ड क्यों ना हो, that has also been produced by a moving charge. तो इसका सही रीजन ये है, for every incoming field there is an outgoing field, या आप कह दे magnetic field exists in a continuous curve, that's why it becomes equals to 0. This would be the valid reasoning. So Anushka, I hope this has resolved your query, and that was a good question. Keep it up, keep it up. All right, now let's come. The south pole is equivalent to negative charge. The north pole is equivalent to positive charge. And these QM, they are called as the magnetic charge, all right? Now you would be interested to know that what does magnetic charge depend upon? The first thing is that, let me start with the unit of magnetic charge, that is ampere meter. That is the unit of magnetic charge. As contrast to electric charge का जो unit है, that was coulomb. जबकि magnetic charge, it will have a unit of ampere meter, not ampere per meter. All right? Now, fair enough. तो आप कहेंगे, what is the expression of magnetic charge? In fact, there is an expression of magnetic charge, but we don't study. तो हो सकता है आप सोचेंगे अगर पढ़ना ही नहीं है, then that's a good news. Right? That's one of the best answer that a student can give, कि that's not in our course. But let me tell you, magnetic charge का जो expression है, that primarily depends upon the shape. If there is a bar magnet, there is one expression of magnetic charge. If there is a U magnet, or we also call it as a horseshoe magnet, there is another expression of magnetic charge. For another shape, there is another expression of magnetic charge. That is the reason why we don't study the further expression of magnetic charge. But one thing is guaranteed, kuch bhi ho, the magnetic charge is going to have unit of ampere meter. Okay, that is the condition. Now, after going through another point, say, you may be wondering कि ये ampere कहाँ से आया? Like the same question what Anushka had raised, because there are circulating charges, they would be constituting the current, और उसी current का A, the ampere, that is the given condition. But yes, magnetic charge का expression क्या है? That is not required for us, but qualitatively magnetic charge किन किन चीजों पे depend करता है, that is very much important, and that is very much within our syllabus. So let's see कि magnetic charge depends upon, now this is very very much important, किन किन factor पे that it depends. Let's see. The magnetic charge depends on, number one is the strength of magnetization. So strength of magnetization, all right? Magnetization, that's cool. So if you have magnetized a substance to a very high intensity, the strength of magnetization would be stronger. So that is one part. And there is also a second dependence. There is also a second dependence, and that is the cross-sectional area. Now the cross-section area of what? The cross-section area of the bar magnet. So Shant Verma, you have said Q equals to current into distance. Dimensional sense में कहेंगे बिल्कुल सही है, but simply इतना कहेंगे कि current into distance, then we need to open up which current, which distance. So इस झमेले में हम पढ़ेंगे ही नहीं. Okay, so yes, ampere meter है, तो आपका जो आंसर है, that is in a form of dimensional part. All right, आगे बढ़ते. The cross-sectional area, इसका मतलब, suppose if I say, if I cut this magnet here, यहाँ काट दूँ. Of course, when I cut it, that means it would be cut in this way. Now the cross section area, आप देखें, the value of the cross section area that changes, और अगर cross section area changes, the value of magnetic charge या इसे pole strength ये भी कहा जाता है. So let me write this particular thing, magnetic charge, or a very important word, pole strength. Okay, that is the condition that changes. And if I half the cross section area, the pole strength would also be halved. So that is the condition. Usme there is a direct proportionality. So that was about the idea of pole strength or magnetic charge. Now in that context, we have something which is called as the magnetic moment. Now let's try to see. What is a magnetic moment? Let's try to understand that. सबसे पहली बात, यहाँ पर आते आते there are lots of confusion which will emerge. आप नहीं चाहें तब भी, अगर आप seriously पढ़ाई कर रहे हैं तब तो confusion और ज़्यादा आती है. So it's always very important that how do we address this given topic. आप देखिए magnetic moment. तो पहले एक बार let's try to understand why is this term necessary. उसके बाद calculation में जाएंगे, right? The first thing is that, see, the clue word, the magnet always exists in a dipolar form. Now this has been established and there is no doubt in this, there is no confusion in this, okay? So it's always in a dipolar form. Now if that is the situation, a dipole will have a moment. Recall the lesson, electric dipole moment. In the similar way, we have magnetic dipole moment. और इसी magnetic dipole moment को हम कहते हैं magnetic moment. So the first thing is that you could really understand, you could really realize कि ये जो term magnetic moment आ रहा है, ये कहाँ से आ रहा है. The clue word, that's very simple. Because the magnet always exists in a dipolar form and every dipole has a corresponding moment, so therefore that magnetic dipole moment in short is also called as the magnetic moment. तो यहाँ से आप compare कर सकते हैं, the electric dipole moment there is the magnetic moment here. There, the electric dipole moment was represented by P vector. यहाँ पर it is represented by M vector. There, it was represented by small case p. Here, it's represented by capital case P, M. Okay, so that's the magnetic moment. But there's one more thing, जो electric dipole moment में नहीं था, and here it is present. And you'll really love it. मैं कोई नई चीज नहीं बता रहा हूं, I'm just compiling your previous knowledge. Now let's see. आपको अगर magnetic moment पाना है, if you really want a magnetic moment, then there are two ways how you get magnetic moment. Let me repeat it again. Magnetic moment पाने के दो तरीके हैं. You know what? एक तो है आप permanent magnet रख दो, झंझट खत्म, no any trouble. So the permanent magnet, you have a dipole, that's a permanent magnet. But there is also a second way, और वो है a current carrying loop of any shape. The current may be clockwise, anti-clockwise, that does not matter. So just keep this thing very firmly in your mind कि magnetic moment achieve करने के दो रास्ते हैं. या तो एक permanent magnet रखा जाए या एक current carrying loop रखा जाए, दोनों equivalent है. दोनों से एक ही outcome मिलता है. The outcome is same. Now it depends on application to application. जैसे जहां पर rotating device हैं, for example generator, for example motor, तो वहां पर mechanical motion है, wear and tear of these objects may occur. So people do not, people do not want permanent magnet in a rotating device. वहाँ पर current carrying loop रखते हैं. इसीलिए in the fan, in the motor, बहुत सारे windings होते हैं. The primary purpose of that is to create a magnetic moment. बहुत बार क्या होता है कि पंखा खराब हो जाता है. You call an electrician checks it और वो कहता है कि इसकी winding खत्म हो गई है, इसको rewinding करनी होती है. So yes, he is saying that it needs to be rewinded, but actually he wants to create more magnetic moment. That is the answer. So either you do this or you do this, but today we are going to concentrate on this particular part. All right? So here comes the magnetic moment. And how does it come? The idea is very simple. This is minus qm. This is plus of qm. And similar to electrostatics, यहाँ पर similarity है. Okay? Similar to electrostatics, the dipole moment would be in the direction of negative to positive. In our case, south to north. That's how it comes. And this is how we come up with this point. This is how it comes. Yes, so someone says that, does qm depend on the temperature? Yes, qm certainly depends on the temperature. But the relationship with that is, on a rough scale, it decreases because randomness will increase. But exact expression के लिए you need to go through the quantum physics. But yes, certainly, because the randomness increases, so temperature part will have a great dependence on that. That's a good thing. That was a good question. All right, so now let's come to this point. Minus qm plus qm, and this is the magnetic moment. Now let's try to see. If this length is L, the direction of the magnetic moment is from negative to positive, or magnitude की अगर बात करें, that's qm multiplied by L. और आप देखें, the unit of qm, that is ampere meter, this L is meter. So if I go completely, that comes out to be ampere meter square. That is the magnitude of the dipole moment. qm into L, and the unit comes out to be ampere meter square. Dipole to dipole, any difference, sir? ये क्वेश्चन मैं ठीक से नहीं समझ पाया. नीलेश दृष्टि, इसको एक बार rephrase करें. So this is how we talk about the magnitude of the dipole moment, and because it's a vector quantity, vector से संबंधित तमाम properties magnetic moment के लिए भी valid रहेगी. So any given properties of the vector would be valid for magnetic moment. Let's have a question. Here's a question to you. Find the net moment. You got to find the net moment. This is m, this is m, this is 2m. Yes. So this question is for you. आप इसे solve करें and please post your answer. And this is an equilateral triangle. Length L, and length L. Okay. So please post your answer in this WhatsApp number 9311883484. I need your answer, guys. M is in cross product. Anshula, please rephrase your question. I could not understand. कौन से cross product की बात है? आपने question भेजा है. M is in cross product. There is a question, was JEE exam similar to last year? No, this time it was it was comparatively simpler than last year. काफ़ी आसान था. हो सकता है कि because of the pandemic, people loosened the standard, but it was quite easy. लग नहीं रहा था कि ये JEE मेन का पेपर है. मैं फिजिक्स की बात कर रहा हूँ. All right, people, waiting for your answer. आपको निकालना है net magnetic moment. Zero नहीं रोशन, it's not zero. आप ध्यान से देखिएगा, the value of magnetic moment. No, Anushka, it's not zero. ओके चलिए एक बात देखते हैं नाउ. आई थिंक आई नीड टू वर्क अपॉन इट. बहुत ध्यान से देखिए, ये m और ये 2m, दैट्स अ गिवन कंडीशन. नाउ व्हाट यू कैन से इज दैट इस 2m को आई कैन ब्रेक डाउन इनटू m and m. दिस इज व्हाट आई कैन डू. ये जो 2m है, लेट मी ब्रेक डाउन इनटू m and m. दिस इज व्हाट आई वुड लाइक टू डू. तो आप देखिए, ये m और एक m अगर आप उठाएंगे, the resultant will be 0 because of the property of the vector that 3 vectors in order forming a closed figure, which is the triangle in our case, the resultant is 0. तो ये चीज आ गया. Yes, Anshula, your answer is correct. अब बचा जो additional है, that will be having a magnetic moment m. यानी the resultant magnetic moment that is equals to m. ठीक है, क्या किया हमने? this m and this m. The resultant that was 0. There is one m which is uncompensated. तो वही है the resultant m. तो देखिए, हमें बहुत ज्यादा सॉल्व करने की जरूरत ही नहीं पड़ी. A little bit of property associated to vector and you get that answer. Okay. All right, now let's go to the next thing. This was about calculating the magnetic moment. अब जरा देखते हैं the magnetic field produced by a magnet. And this part is very, very similar to the computation of the electric field by an electric dipole. So let's try to understand that, okay? So this is what I'll be getting. Rajan ji, please show the timer as well. I'm not okay. ठीक है. Yes, Nilesh Trishti, अगर आपका आंसर M आया, congratulations bro. आप बधाई के पात्र हैं. That's very good. Okay, there's one more. I hurried unnecessarily. That happens. That happened. Is it the okay. Anshula, it's not the cross product. आप देखिए, this is reason है m vector equals to qm into L और एक देखिए cross product. There is a good question asked by Anshula. She says that is the cross product of qm and L, is it m? The answer is no. क्योंकि cross product होने के लिए सबसे पहला शर्त we require 2 vectors. जबकि आप देखें ये scalar है, इसको आप तब भी vector मान सकते हैं, but the magnetic charge that is scalar. So therefore it's not a cross product. So hope Anshula your query has been resolved. Okay guys, so now हम बात करेंगे computing the magnetic field. Magnetic field को compute करेंगे और इसके लिए we will go in a similar tone to that of electric field. The first thing is that there is something which is called as end-on position. There is something which is called as the end-on position. So if you talk about the end-on position, so here is there, ये है magnetic moment. Right here there is an end-on position. So right here the direction of the magnetic field is this. Similar to that of electrostatics, the direction of electric field was in the direction of the magnetic moment. And the value is going to be 2 km divided by r cube. There it was 2kp divided by r cube. जरा सा ध्यान से देखेंगे, electrostatics, complement में that goes in a revised state. मुफ्त में revision होगी electrostatics की. Okay, you'll get a complementary package. So here, that is 2km by r cube, but there is a difference. जहाँ पर the value of k here is mu naught by 4 pi, while in electrostatics it was 1 by 4 pi epsilon naught. So that is the major difference here. So that's about the magnetic field due to a dipole, and actually it's an ideal dipole in an end-on position. Now let me tell you, at 2:30 I have another live session, and that will be about thermodynamics. So if you feel that you want to revise those thermodynamics, we'll be keeping in a neutral tone, valid for both JEE Main as well as NEET. So all you people are most welcome that attend that session of heat and thermodynamics, where we'll be talking about first law of thermodynamics. SI unit of length is meter, so how come QL is ampere meter square? Anamika, actually ये जो Q है, ये electric charge नहीं है. It's a magnetic charge. Probably you attended this session a bit late. We had talked about it in the beginning. The magnetic charge has the unit ampere meter. So now your query will be resolved. Ampere meter multiplied by meter, that's going to be ampere meter square. Okay? Alright. So ये है the magnetic field due to an ideal dipole in an end-on position. Now there is a very beautiful difference. Let us contrast with the electric dipole and magnetic dipole. It's a simple thing, yet many times unnoticed. I don't say it's difficult, but it is unnoticed. क्या है? जरा ध्यान से देखें. One, I have electric dipole. That's first condition. The second, I have magnetic dipole, minus QM and plus of QM. So one is the electric dipole, the other is the magnetic dipole. Now let me try to draw electric field lines. So bahar, the electric field lines will go from outside, it will go from positive to negative, or inside also from positive to negative. While in case of magnetic field, that's very simple. Outside to inside, everywhere the field line is continuous, that's how it goes. So that's the magnetic field line. आप कहेंगे इसमें कौन सी नई बात है? Because at least this property we do it very very properly. बहुत ज़्यादा करते हैं, right? We talk about that. So what is that new thing which is generally unnoticed? Let me show it to you. And that is this guy. कि आप देखिए इलेक्ट्रिक डाइपोल मोमेंट की जो डायरेक्शन है वो P है, और this is the magnetic dipole moment. Did you notice one thing? Within the dipole के भीतर, the electric field is opposite to that of a dipole moment. And within the dipole moment, the magnetic field is in the same direction of the magnetic moment. तो जब हम axial position की बात करते हैं, we talk about outside. तो बाहर, there is a similarity. The direction of electric field is same to the dipole moment. The direction of magnetic field is same to that of magnetic dipole moment. So outside, it's all same. But inside की अगर बात करें, the direction of dipole moment and electric field is opposite. The direction of magnetic moment and magnetic field, that is same. It is very simple, yet many times it goes unnoticed. So just take care of this fact. Does the value of mu not depend upon the material of the magnet? नहीं. Mu has no dependence with the material of the magnet, Anushka. mu depends on the medium where you are computing the magnetic field. So mu is about the medium, not about the makeup of the magnet. All right, so now let's see, that was about the axial position. अब बात करते हैं broadside on position, जिसे हम कहते हैं equatorial position. So this is another one which is called as the equatorial position. Now in case of equatorial position, see, this is the magnetic moment that's coming from south to north. Equatorial position mein the direction of the field is opposite. Opposite to what? Opposite to the magnetic moment. And you get the value of magnetic field is Km divided by d cube. That's how it comes. Km divided by d cube. Okay, that's the condition you get. जहां पर k की जो value है, that is equals to mu naught divided by 4 pi. So that similarity would still be valid. So इस तरह से हमने देखा the expression of electric field in axial and equatorial, expression of magnetic field in axial and equatorial, they are identically the same. Of course, difference है, और difference किस में है? In the value of k. There it was 1 by 4 pi epsilon naught. Here it is mu naught by 4 pi. So I hope all this thing has been discussed. So there is another question here. Today Anushka is, whose question is it? दिखाइए, Rajan ji. Please show me the name. Anshula. All right. So yes, Anshula has raised another question. In electrostatics, we considered yes, बिल्कुल. तभी आपने एक, let me read the question of Anshula to all people. In electrostats, we considered this expression of B at large distance. Is it the same case here? Absolutely. आपने बीच में एक बात notice की हो या नहीं? I said these all expressions are valid for ideal dipole. और ideal dipole के basic definition में by default it's included कि ये जितने भी computation है, they are at large distance. Okay? All right. So this is what we got. There's another question. The name Aditya. All right. So please show what is the question of Aditya. B equals to Km by 8R cube. ये मैं अंडरस्टैंड नहीं कर पाया आदित्य, आप किस कॉन्टेक्स्ट में कह रहे हैं, एक बार रीफ्रेज कर लीजिएगा क्वेश्चन को. ओके, सो दिस इज व्हाट यू गॉट. नाउ एक लिटिल बिट ऑफ एक्सप्रेशन, लेट्स ट्राई टू सी. लेट अस ट्राई टू सी. बहुत ध्यान से सुनना. सिंपल येट मेनी टाइम्स मिसअंडरस्टूड. आपके पास एक मैग्नेट है, ऑलराइट. अब जरा ध्यान से देखिए. For a given R, magnitude of R. So R is the distance from the magnet. D कह दीजिए, R कह दीजिए, it's all the same thing. So what does it mean for a given R? यानी length की जो value है measured from the center, dipole के केस में every time it is measured from the center, that is same. उसे change नहीं कर सकते. Now here is another question. How many? ये जो एक part है, this, often students get confused while talking about Earth's magnetism. So I'm just helping you clear. How many axial points are there? कितने axial points हैं? That's the first thing. And how many equatorial points are there? But इस बात को ध्यान देना, for a given R. यानी डिस्टेंस सेम होना चाहिए. आप A का कितना आंसर होगा, B का कितना आंसर होगा, 2, 3, 4, 5, 10, whatsoever, please write it. B equals to Km by D cube. How? Nilesh Drishti. There is a derivation. जैसे एक एक के कारण से निकालते, पहले एक नेगेटिव चार्ज जो कि हमारे केस में साउथ पोल है उसके कारण से फील्ड निकालते, पॉजिटिव चार्ज नॉर्थ पोल के कारण से फील्ड निकालते, देन वी डू द वेक्टर सुपरपोजिशन, तब जाके यू गेट द आंसर। थोड़ा ऊपर स्क्रॉल करिए प्लीज, ये इसी पे। नीलेश दृष्टि, प्लीज डोंट सेंड एनी अदर मैसेजेस अपार्ट फ्रॉम एकेडमिक्स। अनफॉर्चुनेटली हमें आपको ब्लॉक करना पड़ेगा। दिस इज प्योरली एन एकेडमिक प्लेटफॉर्म, नथिंग मोर देन स्टडी। ओके, सो अनुष्का सेज 2, क्या दोनों के लिए अनुष्का? ए के लिए कितना, बी के लिए कितना? प्लीज क्लेरिफाई। 2 फॉर बोथ अनुष्का। ओके, अनुष्का सेज 2 फॉर बोथ। बाकी लोग भी भेजो, चलो कम ऑन फास्ट। ओके, अंशुला सेज ए के लिए 2 और बी के लिए इनफाइनाइट। लेट्स सी अंशुला, जब आप प्लीज राइट योर सिटीज नेम। There is some more answer coming out. ए के लिए 2 है, सुशांत वर्मा। बी के लिए भी लिख देते। ओके, लेट्स सी एक बात देखते। एक्चुअली एक्सियल पॉइंट के लिए द आंसर इज 2 और इक्वेटोरियल पॉइंट के लिए द आंसर इज इनफाइनाइट। Okay, so this is Anshula Girdhar from Sonipat. Actually, there are 2 for axial position and there are infinite for equatorial position. आइए इसे एक बार understand करते हैं. Let's understand this. तो इसे understand कैसे करें? Let's try to see that. Let us try to see it. It's something like this, guys. बहुत ध्यान से देखना. What does where is my tool? Okay, here is my tool. So this is the magnet, you see. अब देखिए ये इसका magnetic moment है. Now how do we understand axial position? Axial position का definition क्या है? M vector and R vector. M vector and R vector या तो parallel है या तो anti-parallel है. So these are the 2 conditions. Either M vector is parallel to R vector or M vector is anti-parallel to R vector. So it's something like this. यहाँ अगर आप देखें for a given R, तो R का जो distance है that is fixed. So this is 1 और उतने ही R दूरी यहाँ से लेंगे. So this is another. So for a given R, ये वैल्यू और ये वैल्यू सेम है. सेम दिख नहीं रहा है बट मान लीजिए. ओके, फॉर द सेम R there are 2 axial position, but equatorial के लिए that's going to be infinite. अच्छा, infinite क्यों? Let's try to understand. But before going to that, we need to figure out. हमें figure out करना होगा कि equatorial position की definition क्या है. Equatorial position के लिए the definition is B vector is not B vector, sorry. R vector is perpendicular to M vector. बहुत बार हमें ऐसा लगता है. Many times we think in this way that एक R यहाँ है, एक R यहाँ है, तो equatorial भी तो 2 ही points हैं. We feel that कि equatorial 2 points है. But you need to realize there are infinite points. और वो कैसे? Let's try to understand it. See, if this is the magnet Okay, this is the magnetic moment. अगर आप एक सर्कल बनाओगे, so this is that Saturn ring. So अगर आप एक सर्कल बनाएंगे, कोई भी given point आप देखिए, the distance is r, और वो जो r vector और m vector, they are perpendicular. If that did not give you that realization, let me show it through other tool, and this is something like this. See, आप बहुत ध्यान से देखिए. If that could give you the visualization, that's perfectly fine. But one more, magnet ऐसे रखते हैं. यहाँ है magnet, like half is coming outside and half is going inside. अब आप देखिए, for a given r, किसी भी point पे देखिए, the direction of m vector is perpendicular to r vector. Realize that? The direction of m vector is perpendicular to r vector. तो ये जो हर एक point है, they are the equatorial position. So there would be altogether infinite number of equatorial position. जहां पर क्वेश्चन में थोड़ा सा सेंस डालना है, क्वेश्चन में थोड़ी सी और ग्रेविटी डालनी है, people start modifying question in this level. Alright guys, so here's a quick check for you. Please solve this question. एक magnetic moment यहाँ है, एक magnetic moment यहाँ है. You got to calculate the net field at a comma 0. अगर मान लेते roots and everything, if it is difficult to type, just solve it, click the photo and send it. That's the nice option. Use the present day technology. Okay, Anushka. गलती हो गई है, चलिए कोई बात नहीं, इतने बैकफुट में मत आइए. Don't come in backfoot. Alright, so I've started getting answer. एक आंसर है √5 km by a cube. नाम दिखाइए राजन जी. That's a correct one. Anshula, okay. What is the value of mu? वर्मा जी, mu का जो value है, mu naught 4 pi into 10 raised to the power minus 7 रहता है. Okay, let's see how do we calculate this. बहुत ध्यान से देखिए. To see that, look, ये जो m vector पहला वाला जो x axis वाला, अच्छा, first of all, let's decide where are we supposed to calculate. We are supposed to calculate the field at this particular point, a comma 0. Here we have to calculate the field. अब आप decide कीजिए, for this magnet, this is the axial position. And for this magnet, this is the equatorial position. Let me repeat it again. For this magnet, it's an axial position. For this magnet, it's the equatorial position. Okay? तो आइए axial के लिए, the direction of the field is in the direction of the moment, and the value will be 2 km divided by a cube. That's how it comes. Now let's talk about this field, जो y direction में, this magnet. For this, it's an equatorial position, और equatorial position के लिए, the direction of the field will be opposite to that of the magnetic moment, okay? And the value will be km divided by a cube. That has been done. And I need to find the resultant. So the resultant will be here. And b, अगर आप देखोगे, you can straightway find under root this square plus this square. So that's going to come as root 5 km divided by a cube. That will be the magnetic field. So nothing hyped question, purely in the pattern of NEET, purely in the pattern of JEE mains. So these sort of calculation, please make yourself used to. और बहुत ज़्यादा अपना morale, please don't let it down. The question in NEET and question in JEE mains, they are of simple level. Up to this difficulty level, you can always expect. And these are simple stuff. So now we know the value of magnetic field at axial position, the value of magnetic field at equatorial position. It is now time, let us calculate the magnetic field at a general point. General point का मतलब ना तो axial, ना तो equatorial, that would include everything. So if I want to find the magnetic field at a general point, so now what we are going to do, सबसे पहली बात, let us draw, this is the magnetic moment. ये है magnetic moment. Now instead of making that fancy diagram, एक bar magnet बनाए और उसके बाद all those things, so let's not go into that. Let's simply make a magnetic moment, because now we are more interested in the outcome. ठीक है? And the big thing is that where do we want to compute the magnetic field? कहाँ compute करना चाहेंगे? यहाँ compute करना चाहेंगे. Here. We want to compute the magnetic field at a distance r from the center, and this particular angle is theta. इसीलिए we have said it's a general point. It's a general point. Now just try to see. अगर theta की value, if we keep it as 0, then that point will be the axial position. If the value of theta I keep as 90 degree, that point is going to be the equatorial position. So in that regard, this is the general point. Now how do we solve it? We use the property of a vector. So what property of vector? Let's do in this way. Because this m is a vector quantity, तो vector से associated जितनी भी properties हैं, it is valid for m vector. And the first property is that we can always resolve a vector. तो m को मैं resolve कर दूं, 1, this became very small. Okay, so 1 is here in this direction, and other is here in this direction. यानी m vector को हमने resolve किया है, right? So this guy will be m cos theta, and this one will be m sin theta, right? अब आप ध्यान से देखिए. For m cos theta, this point is axial. m cos theta के लिए, this given point, that would be axial. जबकि m sin theta के लिए, the same given point, that will be equatorial, right? So now what we'll do is that, let's calculate the field. बारी बारी से करते हैं. सबसे पहली बात, let's do due to m cos theta. Because for m cos theta, the point is axial, so the direction of the field will be this, and that is 2 km cos theta divided by r cube, that's the case. Or m sin theta के लिए, this point will be equatorial, so that would be opposite to that. और ये जो value आएगी, that's going to come as km sin theta divided by r cube. So all done. ये एक vector है, ये एक vector है, and when you find the resultant B vector will be this. तो ये है resultant B vector. And let me say this angle is alpha. कुछ तो नाम देंगे, so any name of your choice. So let me call it as alpha. Alpha with what? Magnetic field makes the angle alpha with the r vector. Let me repeat it again. Magnetic field makes an angle alpha with the r vector. तो यहाँ पर you see, I just showed you the steps. How do we derive the expression of magnetic field? But अब क्या करें? Let's just eliminate all this complex figure. Let's simply concentrate on the value. Value में concentrate करते हैं. Okay? Now you would see here, to concentrate on that value, I have the magnetic field, okay, and I wanted to calculate, sorry, this is the magnetic moment. I wanted to calculate the field here. So this is m, this is r, this angle is theta, and then the magnetic field is in this direction. This is the direction of the magnetic field, okay, and this particular angle is alpha. तो बहुत ध्यान से देखिए, the angle between B vector and M vector is alpha plus theta. Let me repeat it again. The angle between B vector and M vector, that is alpha plus theta. After having done all those computation, B की जो value है, that comes out to be km divided by r cube under root 1 plus 3 cos square theta. This is what you get. And tan alpha, that comes out to be 1/2 of tan theta. That is the expression. Not to confuse, please don't write alpha equals to theta by 2. ये ना लिखे. This is tan alpha equals to 1/2 tan theta. And remember, this piece of information is extremely important. Okay? Uh-oh. Some information missing here. So this is that given condition. All right? So आपने देखा, how do we represent the magnetic field at a general point? So that is what you got to understand. So, you know, lots of information about the magnetic field we have found out. Now let's go to the next thing. Let's go to the next thing, and that is dipole in a uniform field. यानी अभी तक where did we concentrate? We concentrated on one fact कि अगर एक magnet हमारे पास है, how much is the magnetic field created by that given magnet? That much we know. But now we would like to see another scenario. और scenario ये है कि अगर मेरे पास एक dipole है, एक bar magnet के form है, and if I keep it in an external field, what are the events that it's going to experience? आइए देखते one by one. The first thing is, see, the dipole will be kept at a general point. किसी भी एक general angle पे रखते हैं. So here, let me, अच्छा एक काम करते हैं. Fair enough. First I'll show you what we are going to do. And ये dipole को हमने यहाँ पर रखा है. This is what we have done. Okay? This is what we have done. And let's say that this is the south pole, this is the north pole, and here is the magnetic moment. The direction of the magnetic moment, that is from south towards north. अब हम देखना चाहेंगे what are the events that it's going to experience. Let's try to see. Now the first thing, guys, you need to understand is that there is an exact similar pattern. जिस तरह से चार्ज को इलेक्ट्रिक फील्ड में फोर्सेस मिलते हैं, in the same manner the magnetic charge will experience force in the magnetic field. So the idea is exactly same. So how do we get to that conclusion? Let's try to see. Let us try to see. So okay. Now first of all, see, realize the north pole is equivalent to positive charge. So ये जो thick arrow मैंने बना रखा है, that is force which is plus qm multiplied by b. Look at the pattern. Like electric field mein we go with q multiplied by e. Here it will be qm multiplied by b. At the beginning of the class itself I had said that see the comparison and the contrast, similarity or differences. Now I will like to go for the next part. Next part mein I get it here. The south pole will experience force in the opposite direction, और अगर magnitude लिखेंगे, there is no point to write the negative sign. The direction has already been shown in the opposite sign. So north pole experiencing force in this direction, south pole experiencing force in this direction. Now the first and foremost thing that we can realize and we can experience right here is कि जो net force की value है, the net force that comes out to be 0. And this is always true. There is no exception. This is always true. But remember, ये तभी संभव है if the field is uniform. मान लीजिए अगर field की value non-uniform होती, in that given condition, the force here and the force here could be different. And if the forces at two ends, if they are different, the net force that can't be equals to 0, right? So non-uniform के बारे में we are not going to talk right now. We are first of all concentrating in uniform field. So uniform field के case में the net force that comes out to be 0, all right? Okay. Now I would like to get the answer from you people. Even in the last class हमने इस बारे में काफी अच्छे से चर्चा की थी that what is the significance of net force equals to 0. I just want the significance of net force equals to 0. What is the significance of that? कि इससे हम क्या conclusion निकाल सकते हैं? Come on people, fire your answer. That will be a gift to me. अगर आप सही answer भेजेंगे, I would really find that yes, you people are genuinely following the lecture series. Okay. F net equals to 0. Net force equals to 0. इसका क्या significance है? Okay, there are answers coming out. Yes, please show. Linear momentum is conserved. बिल्कुल ठीक है अनुष्का. That's a correct one. एक और है. It leads to equilibrium. Okay, that is also one valid thing. For F net 0 means net force on center of mass is 0. Vikram from Kolkata. Perfectly right. आप सभी ने, like Anushka said, momentum is conserved. Anshula says leads to equilibrium. Perfectly right. And Vikram from Kolkata said that it leads to acceleration of center of mass 0. Perfectly right. Or actually अभी के जो context में I would like to extract the answer from Vikram कि net force equals to 0. इसका ये मतलब नहीं है कि the body is not going to move. The body can move. But net force equals to 0 का मतलब है center of mass will have 0 acceleration. और अगर पहले से ही center of mass rest में है, इसका मतलब when net force equals to 0, individual part, yes, ACM equals to 0. Roshan, that's great. Great, Roshan. I think last class we had talked about a story of शोले जहां पर नेट फोर्स इक्वल्स टू 0 से क्या क्या कॉन्सिक्वेंसेस आ सकते. Look here, again the same thing has got repeated. Okay, perfectly right. इसका मतलब the magnet will move या may move, let's better say in that way. But अगर ये move कर भी लेगा, the center of mass will not move because I have assumed initially the center of mass is at rest. Okay, अब क्या करेंगे? एक चीज तो तय हो गई है that the center of mass acceleration will be 0. But let's use common sense. अगर हम common sense लगाएंगे, see, one force is being pulling in this direction and the other is also pulling in that direction. So there is a pull from both the side. So eventually you could see the rotation will happen in this way. Common sense se bhi agar kare, because physics cannot go beyond the observation. One force is there, other force is there, you know, that's what it goes, and there will be a clockwise rotation. Iska matlab, in this given point, there is a torque. There is a torque, and that's what we would like to calculate. So torque calculation may see, because we are into a more like a revision state, so I'll not be going for the derivation, but torque ke liye you would get this thing. The torque is equals to M cross B. This is the expression of the torque, and then the expression of the force, ye to hamesha 0 hai hi hai. So now what we'll do is see, let's try to understand. Yes, Roshan, that's perfectly fine. It will experience torque. Wonderful. Now let's see. These are the two conclusions. वो जो torque हमने verify किया था, yes, there will be a torque. The expression of the torque is this much. और आप देखिए, there is a cross product involved. और हो भी क्यों ना? Because this is a vector, this is a vector, this is a vector. So if I multiply two vectors, and if the result is a vector, तो दो vectors के बीच में there is a cross product which is involved. Arno says that torque is mb sine theta. So all our regular students have now started appearing. जैसे कि मैंने पहले भी कहा था, there is a session at 2:30 about first law of thermodynamics. It will go on a revision pace. Sorry, Amog. That means till now you were forgiving me. I was mispronouncing your name. All right. Okay. ठीक है. That's fine. So Amog, आज जो है आपका सब्र का बांध टूट गया. Today you lost your patience. Enough is enough. Every day I get my name wrongly pronounced. All right. ठीक है. Let's come to this point now. Torque equals to m cross b, f equals to 0. आप देखिए, torque की जो direction पता करने के लिए आपको हर बार वो basic से जाने की जरूरत ही नहीं है. There is no point going through the basic. Look, मान लेते ये magnetic field दिया गया है, and in this magnetic field, suppose someone says that, okay, let me make a little bit of change. ऐसा करता हूँ. Let me make a little bit of change. Here is the magnetic moment. Okay, so this is the magnetic moment. यानी वो कहानी है यहाँ पर. Okay, there is a south pole यहाँ, there is a north pole यहाँ, and let us say, you know, this is a quick exercise for you. You know, we want to exercise, we want to practice torque equals to m cross b. तो इस practice के लिए this figure would be very much equivalent, relevant. So all you people now start flooding your answer. I want the answer. ये जो dipole रखा गया है in this uniform field, please tell me the rotation is going to be clockwise or anti-clockwise as seen by you. नहीं तो पीछे से देखेंगे clockwise, आगे से anti-clockwise, आगे से clockwise, पीछे से anti-clockwise होता है. As seen by you. That means you are seeing this. आपको कैसा rotation दिखाई देता है? Please do that. Thermodynamics session. Yes. Yes, इसी channel में 2:30 Roshan. Yes. First law of thermodynamics will start, we'll have a practice. इसी तरह की session रहेगा. The level would be exactly the same. So I'll be expecting you. Anti-clockwise is what Amog says. Anti-clockwise, all right. Clockwise, there is also one answer. अब तो क्या है, दो ही है, clockwise, anti-clockwise. ये मत कहना कि घड़ी की जो है बैटरी खत्म हो गई है, ना तो clockwise घूमेगी, ना तो anti-clockwise घूमेगी. We will not go with that option. ठीक है. So majority I got anti-clockwise, and some people they have come up with clockwise. तो एक बार decide करते हैं. Direction of torque है m towards b. क्योंकि आप देखिए टॉर्क इज m क्रॉस b, तो m टुवर्ड्स b या तो ये होगा, अगर ऐसा है दैट विल बी क्लॉकवाइज, या तो ये होगा, अगर ऐसा है दैट विल बी एंटी क्लॉकवाइज. बट द रूल, अमोग, यू नीड नॉट बी सॉरी, सही आंसर एंटी क्लॉकवाइज ही है. इट इज एंटी क्लॉकवाइज, अमोग. Because m cross b, see there are two options. या तो m को b की तरफ ऐसे ले जाए या तो ऐसे ले जाए. But the rule of vector says you need to go through this smaller angle. Momita says anti-clockwise. Let's see. Yes, it is correct. Because we need to go through this smaller angle. So yes, this will be anti-clockwise. This will be anti-clockwise. So that's perfectly fine. Okay. So in this way, you're going to calculate that. Okay, now, let me just quickly go to one expression. एक को हम कहते हैं, we should consider the smaller angle, so it will be anti-clockwise. Anushka, बिल्कुल सही. That is the property of cross product. And I'm happy that you have come up with precisely right explanation. Keep it up, girl. All right, now let's see. Equilibrium. Equilibrium का मतलब है, let me just give you a little bit of crash course from mechanics. उसके बाद we are going to relate it here. Equilibrium का मतलब है, total equilibrium means F net equals to 0, torque equals to 0. Akela F net equals to 0, if you write that, that is a translational equilibrium. Tau equals to 0 is rotational equilibrium. But अगर आपके पास translational और rotational equilibrium इकट्ठे हैं, then we call it as the total equilibrium. So equilibrium are of three types. One is the stable, other is unstable. All Kolkata people on our channel today, yes, Roshan, but Lucknow people are also there. I think there's Vivek must be there from Lucknow. So there are people from other areas as well, but Kolkata, they are in majority. Kamonachan. All right, let's come to this point now. F net equals to 0, tau net equals to 0. So let's see. Let's understand. Let's come to this point. Roshan, now I've got only 5 minutes remaining. I want to give it there. F net equals to 0, tau net equals to 0. That's the meaning of equilibrium. और equilibrium के तीन प्रकार हैं. The first one is the stable equilibrium. The second one is the unstable equilibrium. The third one is the neutral equilibrium. This is the type of stable, unstable, neutral. The good example of stable equilibrium is this. There is a cup, there is a katori, and in this खूब भालो मास्टर मोशाई मौमिता धन्यवाद. Thank you very much. I manage alpo Bengali. All right, now let's see. There's a cup, there's a katori, and there's a small stone. Let's try to see. This is an example of stable equilibrium. Now invert that katori, invert the cup, keep this. That's an example of unstable equilibrium. And neutral equilibrium is on a level surface. On a level surface, if you keep it here, this is the example of neutral equilibrium. Now let's try to understand why. देखिए, this is a litmus test if you really want to identify whether it's a stable, unstable or neutral. आपको पहले शुरू में थोड़ी सी बदमाशी करनी होती है. आपको आइडेंटिफाई करना है स्टेबल है, अनस्टेबल है या न्यूट्रल. थोड़ी सी बदमाशी कीजिए. क्या कीजिए? slightly disturb. Don't be violent and don't punch. Slightly disturb करें. जैसे आप देखिए, if you slightly disturb, it comes back to the original position. That's an example of stable. If you slightly disturb, it continues to go in the same direction. That's an example of unstable equilibrium. If you disturb here, it will find a new equilibrium position. Slightly disturb करना है, वो वहीं रहेगा, नया घर जम करेगा. So that's an example of neutral equilibrium. This is how we recognize equilibrium. Mathematically, एक और है stable equilibrium के लिए potential energy is minimum, unstable के लिए maximum और इसके लिए constant. So that was a little bit of crash course from mechanics ताकि बाकी चीजों के लिए भी that's certainly going to be useful. Now guys, what we'll do is that let's try to understand. Quickly, let's see that Momita has sent a right answer, but let me explain it to all people. मान लेते ये magnetic field है, alright? So this is the magnetic field, this is the magnetic field, and initially, look, initially this was the magnetic moment, this was the magnetic moment. बहुत ध्यान से देखिए, theta equals to 0 पे यहाँ net force 0 है, torque 0 है. net force तो हमेशा 0 है, but theta 0 पे torque भी 0 है. ये भी equilibrium है, ये भी equilibrium है, because net force is 0 and torque is also 0. Remember, torque is mb sin theta. Theta 0 पे, theta 180 पे, दोनों केस में the expression of torque that is 0. Now I want to identify what is the nature of equilibrium. तो मुझे क्या करना है, थोड़ी सी बदमाशी करनी है. So I will slightly disturb it. ऐसा नहीं कि you kick it away. Slightly you disturb it. आप देखेंगे the torque will be in this direction. So it is coming back. So therefore theta equals to 0 is an example of stable equilibrium. Next let's see, यहाँ से अगर मैं slightly disturb करूं, then what do I get? The direction of the torque would be this. और पहले the dipole was here. Now the torque is in this direction. That means it will continue to move in the same direction. So this is the example of unstable equilibrium. 0 is stable, 180 is unstable. So guys, class अगर होती तो मैं थोड़ा सा और extend करता, but the TV time does not allow. So this is all from my side, and it was a very lovely interactive session that really increased the level of the class. Thanks for joining me. 2:30 we'll see in the heat and thermodynamics one. Else you can go with the magnetism in the upcoming week. Thanks for joining. Take care. Cheers.